Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. We're already on episode 40, which is pretty nuts. I think I say that like every time I start these things now. Anyway, if you guys haven't been paying attention to my recent streams or catching those, what I've been working on lately is preparing for the release of our 64K synth WaveSabre. Again, I haven't really announced when that's going to be, but we're working on getting this stuff ready. So, hold on, let me adjust some things here. I think we're zoomed in a little too much today. That feels better. Okay. Anyway, what we've been working on is preparing our synth for this release, and as part of that, I've been kind of investigating on whether or not we want to build the synth with SSE instead of using FPU for everything, even though there's some caveats to that. Basically, I want the compiler to be generating SSE code instead of FPU. We originally used FPU instead of SSE because we have to link to some system standard libraries that don't include some intrinsics that the Visual Studio compiler that we're using will expect to be there when we use certain mathematical functions. That's really the short version of it. If you want a longer version of it, I've explained that in some of my more recent episodes. But today I'm just going to, continue where I left off with that now. Basically, the thing that we're debugging most is some of these functions that we're filling in. So, for example, we have to supply our own cosine and pow functions, both for float and double, for the synth to work as we expect it to. What I think I'm doing, or what I'm doing so far, is I've implemented pow with not as many special cases as pow would normally handle. So we have to, what I'm actually doing is either, like we have basically one of two options in order to fix this. We either make our pow implementation actually handle all the special cases that we would have expected. For example, a negative, if you take x raised to the y, a negative x with a integral, an odd integral y should give you a negative sign in the results. Otherwise, it's going to be positive. So that's kind of annoying. So there's a bunch of special cases like that I'm trying not to handle. And the way that I'm doing that is we either fix up these pow functions to handle those, which I don't really want to do because I don't think I want a big pow function in here anyway, especially because we know that it's only the synth code that's using this. So that leads us to the second option, which is that we can just go through the synth and find places where this doesn't appear to give us the correct result and just fix them in the synth. So for example, one of the ones that we did recently was in WaveSabre core here. I believe it was Falcon did this, I think. Yeah, it's in here. Instead of having I had this equation here that was basically this value raised to the third power. And instead what I did is I just expanded it out to two multiplies that reduce this into the same value. And that, again, allows us to get the correct sign on the result without having to have pow handle those special cases. So stuff like that is what I'm basically doing. And I'm just going to continue going through the synth until I find things that, or until I stop getting stuff broken. Zockor says too hot for so much hair. It is super warm in Oslo these days. It's about 85 degrees Fahrenheit. Was that like 29, 30 or so Celsius, and it sucks right now, to be honest. But I've been out in the sun a lot, taking advantage of that, so that's been really good. But the stream may be shorter because I close a lot of the windows and stuff, and I'm going to get hot and shiny. So we'll see how long I actually last in this kind of heat. But yeah, so I'm going to just be converting some songs here with the synth until they break, and then debugging the songs and see where they break, and then just replacing some pow implementations with this kind of stuff. What I'm probably going to do is right now, because we're filling in these functions here ourselves, and they don't actually cover all the special cases that these are supposed to, I may actually not use the pow from math.h and might make my own pow function that just is exactly the same implementation, but then the interface is a little more clear on what you can expect from it, which is that it's a pow with less special case handling. So I'm probably going to do that. Anyway, hi to guys in the chat. Kluash, Maliv, Freeful, Zokwar, Desu Used. Freeful, thanks for the sub, by the way. Really appreciate that. Mad Moose, Vowel Bus, so if I'm saying that right. G Superland, Luna Sorcery, Dascon, how's it going? Good to see you guys. Valbus says, how do you find the implementation of these functions and that you need to port functions to x64? You can't use ASM. Where do you find the function declarations of those functions? So the declarations, I didn't actually find anywhere. I found a list of what they are, but I didn't actually find them. But I just made naked functions that have this same signature. And I figured the signature is just going to, you know, take a double, return a double, for example, with cosine, and then pow, of course, has 2 arguments. And the way I actually found this is I just added some naked functions and I called them in a different project, and I went through a debugger and looked at how it was actually passing those arguments. So that's all I found. And that was good enough to do this. And because it's naked, we can just make our own stack stuff in here. As far as the actual code in this implementation, I found it a couple places. Basically, this core of it here, which uses FYL2X and F2XM1. If you basically search POW, SSE, ASM, x86, you'll find the heart of this, and the rest is just some special cases that I played around with. So that's kind of where that came from. And of course, cosine is trivial because you just need to move from the SSE registers into FPU and then call F cosine. And we only use this to generate a cosine table that we use for sine and cosine later anyway with our own table-based implementation. So it's not like this needs to be very fast. Bob says, is it possible to disassemble the POW from the VSLib and embed that? It should be, but as far as I can tell, these POW functions are really hairy because of all the special case handling. So I thought that this would be a shorter path. And again, cosine didn't even bother because it's this simple. And I think there's some approximation that the VSLibs actually use for cosine. There might also be some licensing issues with that, but I didn't really explore that option, so I didn't really care. I didn't miss Alcama when I said hi, did I? Anyway, hi, possibly again, Alcama. So yeah, so at this point, I don't know what song this was. I'll just play it and find out. But this has been my workflow lately, is just convert a song and then play it. This seemed to not make any sound. I'm actually going to enable my system audio for you guys too. Or maybe it already is. No, because I'm not getting the... 1 second here. I plugged in and unplugged some audio hardware today, so all my settings are fucky. There we go. So that pop you hear, that's what we're trying to debug. Now, I don't remember which project this was. Okay, it's our reference project. So what I'm going to do is open that in live. And I'm polluting our stuff a bit here, but it's going to be fine. The guys won't hate me too much. Let's see. Someone was having fun. Music disc, finals. And I should have at least in debug, yeah. So I'm going to just copy and paste this reference track here. Reference debug. And then we're going to open that in live. And live thinks it crashed at some point because my machine restarted for updates. That's annoying. Make sure this has the right output. Okay. And now we'll open reference debug. So the first thing I'm going to do is I'm just going to solo some stuff and then just do conversions and see that those actually work. That alone should get us pretty far. By the way, I just saw DJ Hoffman's Twitter pic on my hosting me list. And that's an awesome picture, by the way. Okay, this track is loud. Let me know if it's too loud. It probably is. Yeah, just looking by my mic level, this is too loud, but this is one of my favorite WaveSabre tracks that we've done. Thanks for the bits, Jura. Getting that proper Oslo tan on. All right, so this actually broke right away in the replayer. So what I'm gonna do Maybe instead of soloing stuff, I'm going to mute stuff. Because we kind of got to do, like, we don't really know where this is going to come from. So we're going to do kind of a binary search here. By just muting half of these. And see if it still just breaks right at the beginning. Something like that. So because of our workflow here. Uh-oh. Error saving the file. That's not good. Okay, anyway. So I'll save this. And then I go into our stuff here. And I just rerun the converter. Run that again. And then I'll go into this player test thing here. Whoops. And rerun that. And we should. And it pops again. So let's mute some other stuff. Molly says, was this in a demo? No, it was not. We released it as an executable music entry for Tursock 2015, I think. So let's just mute all these to make as a control. Let's see if it pops again. Then we'll start bringing things back. And we have saving issues because this is in Google Drive, and Google Drive sucks at this kind of stuff. But that's fine. Convert that again. Run this. And it popped again already. That's very interesting. Yeah, probably Mad Moose. So I wonder if you mute absolutely everything. Does this still happen? Oh, also, hey, this is stupid. I'm not converting the right file, I think. So we need the debug one. So I'll update that too. Whoops. Okay, now I can't find start and end times for the song because everything is muted. So I'll enable the loop thing to get around that. And we have to change some stuff so Live actually knows we edited crap. Okay, that should help. Okay, so no pop. That's a good sign. And then we'll just start adding things back. These buses, we'll do that first because that makes most sense. I'll just do a run with that because this is so fast. Convert, and we see what's going on. No pop, that's a good sign. Just buses, but still. And we'll add back a bunch of these. And save that. And do this again. And run that again. Okay, now it's working. So it's something else. That's exactly what it is, G Superlin. Nice one, Dascon. So, we know it's not one of those. So now we start a snare attack key. And just hit these. And there may be problems later in the track, by the way. We don't know that that's not the case yet. But we need to solve one problem at a time here. Although I'm guessing. All right, so there we go. One of these ones. Closing in on it. Convert and run the player. This workflow isn't too bad. Okay, getting closer. We'll go there. See what happens. Okay. Was it these last couple? Let's see. Again, this is just to isolate where we're going to look in the code. Bang. So move that one. Let's go one by one now. See which one of these it is. Okay. Let's try acid. Otherwise, it's one of the shakers. SKS, just so you know, my doppelganger lives in Berlin. Who might that be? Okay, it looks like it's this acid track. And just to be sure, I'm actually going to unmute everything else, which may not be the best way to do this scientifically because we might uncover something else that has a similar problem, but I just want to try it anyway. Yeah, okay, it's definitely that track for this problem so far. Good to know. So we can actually solo this and just do this here with these loop points because the converter actually respects these. So if we do that, we should get a pop. Nope, we didn't. And it doesn't seem to have soloed that correctly. I don't think the solos work properly actually in export now that I think about it. Let's just get rid of everything else then. Let's do that. So that's the sound we want to hear. Super crunchy acid thing. And it pops. Good. Okay, so now in here, we just do basically the same thing with the effects. I'm just going to mute all of them except the original slaughter. And then we'll know if it's in the slaughter or not, and then we can go device by device and track it down. Okay, so that works so far. Exactly, Juicy Berlin. Make sure to take everything I say out of context, by the way. That's kind of how it's meant to be presented. So we'll enable half of these. Juris says, what's that tracker? I don't recognize it. Yeah, Juicy Berlin had it right. This is Ableton Live. It's what we use in Logicoma. And that already broke, so it's one of these. I'll remove these, and then we have echo or scissor that's left. And it might even just be certain parameters in these that are making it go busted. We're gonna find out. Yeah, Ableton Live is just kind of a... Okay, that works now. Ableton Live is just kind of a common denominator tool that all of us in this group use. Especially for WaveSabre stuff. It was one of the first things I had a converter for. Okay, so we're good there on that leveler, and it seems to be the scissor that breaks it. That makes sense, because I think one of the shaping modes here, and yes, the type is all the way to the right here, so I think that particular kind of wave shaping might use POW. And if that's the case, then that's definitely what it is. I probably have just a crazy exponent or something. Pop, okay. That's the one. So what we're going to do is go into, what was that again? Scissor. So our distortion unit. And I believe that this particular instance, yeah, the type was all the way to the right. And if I know my code, that's going to be this one. Here we go, yeah. So POW V with 30. And it looks, or with 3, so it looks like this already. If this was going to be a negative value, and of course it is going to be, because I think this is just the input, which is just the signed value, and raise that to the third power just to shape it like a parabola. That makes sense. So this is another case where we can just do V times V times V. We're going to see a couple of those, I think. There's also this one, this POW here. But I think this drive ends up being from 0 to 1. Yeah, because you can see this just uses the value here in the set param, get param. So that's going to be 0 to 1. And then if it's less than 2, we do this. Otherwise, if it's greater than 2, we do this thing here, which is only positive numbers. So I'm actually going to I'm going to keep this, I think. And that should actually fix it. So we just have to run this again. And as you can see, that's very distorted because there's some additional stuff after this that'll do all the limiting on that. So if we save this and convert it again, then it shouldn't be super ridiculously loud. And then we can see if this whole track is fixed. Now it sounds like it's supposed to. Sick. Awesome. So now I'm going to remove this loop stuff and unmute everything. Get wrecked, bug. Rip, bug. Okay, and then we play this, and we should hear the whole song. If not, we'll just keep going. So now we get to enjoy this track. That's kind of the nice part about doing this. I suspect fixing this will actually fix a lot of them. I tend to not use this WaveSabre. But the other guys seem to like it a lot. I mean, it sounds great, so good thing we have it. I believe this won the executable music compo in Tursock 2015. No, I haven't looked at the code for other use cases of POW. I'm guessing that could also be worth doing. It might be faster than finding it through the tracks, but I'll probably do both. But I'll keep doing this workflow because it's really fun. Get some water. Thanks, Jura. Yeah, the drums are Hoffman. The other sounds, I think, were more me in this drop. But there's a lot of both of us here, as is usually the case. I know you guys might not be able to tell, but it sounds to me like there's a couple things wrong here, but I'm going to keep going because I'm guessing they'll become more obvious later. And then again, when I'm done going through the tracks, I'm going to do just searching through the code to find similar usages of POW. says he used last time he assumed he had a problem with floating point functions, and holy crap, there's so many edge cases. Suggest looking at the muscle implementation of POW to see and implement the edge cases. Yeah, I'll definitely. I actually want to take a look at that as well. But this seemed good enough, I think. I mean, there might have been some things that sound a little weird, but I'm gonna ignore that for now and just look for some of these more obvious cases. But let's go ahead and listen to Rubik, which I know caused some problems before, right when the drop hit too, so it's really annoying. Thanks, you super. Yeah, glad you guys like that tune. I think that's my favorite one that Hoffman and I have done together, except maybe this one. Quick reminder that both this track and the last one both fit into a 32K executable, which I'm super proud of because of the synth. But of course, this song was used in a full-size demo because Smash the Fairlight didn't have a soundtrack when he showed up to Nova last year, so we donated this to that as well. Exactly, Juicy Really. That's definitely this movie. Exactly, Nolive. Definitely that one. Jira says N64 port win. This thing's barely real time on a modern CPU. Okay, that seemed good. So let's try some more of these. Yes, CE944. That's exactly what we're doing. We parse the project file to get all the routing and which devices are used, and then we take the device blobs out of there and put them into our data blob that we ship with the executable. and then the synth will deserialize all that into the synth object graph and then render everything in real time. That's the whole pipeline. If you're more curious about that, I totally have another stream about WaveSabre specifically where I go over that stuff. So I think this Varia track didn't work before. I'll try this again. This is I think the first, like, this wasn't the first song I did with the synth, but it was the first song I did with most of the modern elements of the synth. Back in 2013 or so. Oh, cool, CE944. I didn't realize you were a dev. I must say, reverse engineering that format wasn't very fun. Seems to be going fine. Sounds a little bit different than I remember, but Hoffman did some re-leveling and stuff for the release, so it's probably good. The other thing CE944 that helps us a lot, of course, is that we only support a subset of what Ableton Live supports, so only needed to do a few things. There's a lot of information in those files otherwise. SK Test, what do you mean by radio stream? And to get my timer back. Oh, nice. Thanks, you, Cyberlin. Thanks, Dascon. And that quits a little early, but that's fine. That I'm going to want to go fix later, but that's a separate issue. Try backscatter. I don't remember which ones worked and which didn't, so I'm just going to run through all of them anyway. I don't think we have the SK Test, but we do have our SoundCloud, although I don't know if it has all this stuff in it. Later when we get the music disc out, though, you can enjoy that. Yeah, G Superlin, we're totally planning on doing that. We're looking into doing that for all of our music, actually. Daniel Colin, we're totally planning on releasing the synth and the tracks. That's what I'm doing all this work for, actually, is in preparation of doing that. So all these project files will come with it, the whole synth, the whole converter suite, everything. Because the value of this synth is basically only there if it's open source anyway. Lunar Sorcery, I think those streams would be useful for learning that stuff. I don't know if it's best practices, but definitely studying that architecture I think you'll learn a lot from. I did a stream a while ago. Let me dig that up for you. Fading out anyway. So Luna Sorcery, this link here. Oh, whoops, I hit escape. My bad. Oh, wait, I didn't click. Oh, crap. I hate Windows sometimes. 1 second. Let me find this video again. Because I did a stream where I was talking about audio, but I ended up talking about a lot of the architecture for that emulator and a lot of really good things about it. So I think if you're looking for emulator architecture, that would be a really useful stream for you to watch in particular. So let me get that for you. So there's that. Also, Jura says, will you release the conversion tool also? And then definitely, because that's a very integral part of actually using the synth. Like, my hope is that people implement their own devices within the synth framework, and having the converter tool and some instructions on how to use that in addition to all the synth code itself is going to be absolutely necessary for that. So yeah, all that plus a music disc with a bunch of these tunes and some new stuff is totally in the pipeline. So yes, this is Barefaced Cheek. I think Hoffman and I did this for Revision 2015. And I can't remember if we won or if we got second. I think we got second. I don't remember. I'm just going to look it up. Yeah, it was Revision 2016 and we got second. Exactly, Molly. SKTS, it should totally fit on a floppy. By the way, I'm going to turn this up. This is so Hoffman. so that works. Again, I don't remember if Elysian worked or not. I think it did. I think this is one of the ones that worked first when I started doing these conversions. So I'll test that. It's so fun to go through all these songs like this and get them to work again. Like, it's... I'm really proud of the work we did here. And this synth is 6 years old now. It's crazy. At least the core of it. Daniel Colin, the synth will only work on Windows currently. We do have some work on a Mac port. At least for the tooling. So I'm just going to repeat that because I don't know if you heard me, but we are actually working on some Mac support as well, at least for the tooling. But the replayer for now is Windows only. At least for some codec stuff, so it could be possible to make it cross-platform, I guess. Dan Collins says you use some Windows samples and such. We use GMDLS samples, but that's it. And that's an easy file to ship around. Bob at B8 plans to release the documented reverse engineered Ableton format. I didn't really do much documentation of it other than the actual converter code, so I don't really have such documentation. I don't plan on writing it. The converter code is probably just going to be all we release. I do think this does work in Wine, actually. This song never gets old for me. It just meant a lot, that whole intro. And we'll do engage. Thanks, guys. And if this works, we have one more, and then I verified they all basically work. I still want to go through the code again. I'm also going to make it use our own POW instead of polyfilling the standard one, just so that we make it clear that it's our own thing. But yeah. That would be really funny, G Super Berlin, and super annoying. Content ID destroyed. That tickled me. I loved all those, you guys, but POW bypass has to be my favorite. Just with all the context here. That's great. It's so funny how it just... all you need is caps for that reference to work. That's awesome. Yeah, exactly. I'll call it. It's paw. Paw's saturated. All right, I think this is the last one that I actually need to test. This, by the way, a very special track to me. This was the first one that Hoffman and I collaborated on with the synth. And in a way, the start of Logicoma. Exactly, juicer for that. How was Rustfest, by the way? I forgot that was this weekend. It all seems to work. So that's great. I still want to go through and actually search this code for instances of actually calling POW. What I think I'm going to end up doing is, instead of actually using POW or POWF, we want to find both. I'm just literally going to go file through file here because it's not going to be that slow. I'm actually going to replace them with calls to our own function here. Let's even change the exponent. That's a fun one. Hey, Metalloids. But yeah, so instead of actually calling POWF from math here, I actually want to do our own function. And again, that's just to make it more clear that we're using our own implementation rather than whatever the system standard one would do. And the fact that it kind of tells the user that these might deviate a bit. So I'm actually going to do this. Actually, let's stick it on the top here. We'll do POW double X double Y and float POWF. And what's kind of nice here is I'm just going to take these CRT functions out of here and just put them in the other one, just inline. Although I might have to do some stuff because I don't think these are naked now. Move some crap around here. I hate that it changes the indentation and a bunch of the other stuff that I did here. But it is what it is. There's some formatting things that I don't agree with here. I don't think this would be too hard to port because we could just do if-defs here for the platform. Which would make enough sense at least. There goes my Slack. I forgot to close that. I mean, could do it in assembler too. It's just easier to put it in the code in Visual Studio here by doing it this way. I don't want to remove this CRT thing because I think we still use cosine from there, but I might inline that too, to be honest, because I think we only use it one place. And that's actually here to generate the table for cosine. So it's actually only here that we do it. But for now, I'll just go ahead and remove these other POW ones. And then everywhere we use POW, or until we remove all of them at least, we'll actually get compile errors or link errors. So we'll actually get. But I think if we just make these naked, we're good. They're static anyway. So I think that should work. It might not. We're going to find out. I think that's what you do for that. Naked can only be applied to non-member function definitions. Okay. Let's just not do that then. Or actually, I think, did I just not mark these static? That would have been dumb, but I wouldn't put it past me. Okay, but it's still a member function of this. This should have probably been a namespace for a lot of these. But I think this is okay. Okay, so then these aren't going to be naked. And then I think the only thing really that we need to do here differently is that. Just remove the red. And I can do a disassembly on this too and check that later. That shouldn't be too bad. But I mean, if it works, I'm not going to worry about it first. Anyway, we still need to go through and actually have this call these. So I think it was in one of these already. Crusher here, where we did powf. Instead, this is going to be helpers powf with the exact same signature. We do still want math because we'll use floorf from that. Okay. I'll just keep going through here. If I find these, this one should be good. Leveler should be good. Scissor, I think, is powf here. And this is not going to do that now. Let's just remove that and see if that's the only thing. And it is. So this will be... Okay. That one doesn't use it. That one doesn't use it. That one doesn't use it. This one shouldn't either then. And this one, we'll see. Oops. Nope, good. So then we check our filters and stuff. I would expect to find some in here pretty quick, but maybe not. We also get to remove all the fixed denormal stuff eventually. Really looking forward to that. It's one of the reasons I want to look into this. So this one, we have powf here and absolute, so we'll keep math. But this becomes helpers powf. This also, the other reason I want to do this as part of this helpers thing is this will actually help this from polluting anything else that might try to link this code and get a bad POW implementation, not expect it. So this is the way to do this, the way to package this at least, but I didn't arrive on that solution until after I had started writing my implementation, so that's why I did it this way. And here we actually use it in helpers itself. That's fine, because we'll just do helpers pow. Perfect. In fact, I think we don't need to prefix the names here either. That should be in scope. Oh, can I do a colon? See you later, Descon. Side crusher run. It's not this one, is it? Maybe this one you're probably thinking of. Because we could do the reciprocal here. Ah, it's probably fine though. this actually might be something we could do better, but just trying to remove clues if we can, or includes if we can, but we can't there. I think that might be it. And it popped. That's annoying. Very annoying, actually. But that might have to do with me doing something wrong with moving this implementation. I would not put it past me, to be honest. Another thing I might want to do here, actually. We'll see. Yeah, I'm thinking the same thing, Daniel Cullen. There's a really easy way to get around that, which is going to be this. I'll call FPU POW. If we just do this here, then I can probably move around the code if I think that's ugly. Yeah, gotcha. Did you see Berlin? Good call, but I already had it. Things would go bad otherwise. Well, they did go bad. Wonder why, actually. That seemed worse than before. Oh, I did forget the ret. Haha, nice. Say I already got it, and then I mess it up anyway. So me. Okay, so that popped again. I wonder what the issue there is. We shouldn't have changed much. I should have actually committed by the time I started replacing these. That's pretty funny. I'm probably going to fix this, and then I'm probably going to head out, by the way. And then the next time I sit down with this, I want to actually do some speed tests on whether or not this is faster. I also want to get rid of those denormal things. I have all this written down in my notes, but just sharing with you guys what I'm thinking. And let's see. I mean, what I could do again is try isolating stuff, but this is, let's actually just do a git diff on this and see where I'm at. See if I can see anything obvious that way. A lot of stuff in here has changed, though. The song blob crap. Skip all that. It's just that I exported a different song, which is kind of funny that it does this. Can I just do end on this, actually? I can work my way up. Just make sure I didn't do anything stupid. Looks good there. That power to the power 3 looks good. These substitutions look good. It might also be something stupid like stack alignment or something. Because with us implementing that initial POW function, there might be additional things in that signature that we're not codifying here that the compiler doesn't know about. I don't think that would be the case, because as far as I know, well, I don't really know that much about how SSE variables are passed around in the ABI for Win32, so could be some messed up stuff. Obviously, this assembler code hasn't really changed at all, and the signatures here should match what I had before. That's a fix I did last time that I know is correct. That POF to POF looks good. From what I can tell, at least the way that these functions were done previously at least for the intrinsic implementations, it would actually return in XMM0, for example. So this would actually pass only in the registers. We'd have XMM0 and XMM1 for the arguments, and then XMM0 would be the return value. I need to look that up, actually. SSE Win32 ABI. See if I can find anything. I may have to look at some disassembly here. I would not be surprised at all if that was causing the problem, by the way. There is some stuff about stack alignment in the x64 calling convention. And I wouldn't be surprised if this was stealing some of that stuff, but I can't actually tell. At least these loads and stores that I was doing shouldn't care much about that, as far as I understand. This formatting got messed up. Yeah, we build 32 or WaveSabre with 32-bit on Windows. You know, and these don't need to be naked either if I can find the right implementation that fits with how this other stuff expects to be called. Here's what I think I'm going to do. I'm going to pull up that other project that I had where I was just doing this stuff in isolation and try to package these functions in the same way, like get them to have the same signatures and see what the compiler is doing for that. So in this case, that should actually be really easy because we'll just do our own POW stuff here. Same thing here. In fact, I might even just call these. We'll do a couple things here. Do this and this. And I'll just copy these. Or even I'll just do this. We'll just do the signatures here. Or not even that, right? Because I think we can just do that. I think this might be a problem, actually, that we declare it like this, but we'll see. I can just call these directly, right? See if that breaks anything. Can only be applied to non-member function definitions, which is the case, right? Maybe it's this that it doesn't like. Seem to be okay. If I run that, I get some crazy stuff. But I just want to look at the disassembly here. So X32 DBG, which I'm actually using more than Ollie these days, has the same interface, just looks a little better. And that is the wrong executable that it ran. So I gotta run the other one. Run this. Main CRT startup. I think this is step over. So we want to get to this one. So we'll run that and then step into this. And in main, so it looks like it moves the input into XMM0. That's calling cosine. So we care about POW here. What I'm seeing is it looks like it's passing these on the stack now. So that's probably the issue that we have. If I'm reading that right. Oh, hey, this is actually going through FPU. That's what these FSTPs are doing. That sucks. That is not the signature we wanted these to have. This might present a problem for this approach, actually. I mean, I could just go through the FPU anyway because that's what I'm using internally. Like, the only reason I was even using those XMM registers was because that's what the calling convention was. So I might as well just make these use FPU since that's what yeah, I'll do that actually. And so in that case, I can just fill that in here and get them to how I want and then move them to the other stuff. That should be fine. So I think this one's going to be easier. Well, I guess they're both fine, but so now instead of doing FSTP into ESP here and then move SS, we actually just want to leave that value as our return value, not move it into XMM anything. The arguments are going to be different, but I don't really know how those are going to be passed off to look at that again. Then we may not even need ESP here. Need to adjust this. Is there any other return here? I don't think so, except this would just jump to done. Because this would do FLD1, FSTP this, because we're returning 1 there. So we can remove that too. In that case, I think that's basically all we need to do there. Same with this. Whoops, we do not want to remove those. So I should actually maybe just run this normally. Now we get some results, but I don't think they're the right results because I don't think it's reading the arguments correctly yet. Oops, I have two of these. So now this should reopen the right one. No, it didn't. Okay, run this, go here, step into here. The only reason I'm not doing this in the WaveSabre project itself is just because I'm removing as much other stuff as possible when I'm adjusting these functions. Because it's really confusing when you have to dig through a ton of stuff in the debugger. But now as we just go into this main function that calls these, it's really not bad at all. Anyway, from what I can tell, it ends up loading the argument into XMM0 and then it pushes it onto the stack. So I think push ECX here is just a 1-byte instruction that just allocates some space on the stack, 4 bytes of that, and then this unaligned pack single is just moving that from the XMM register into that. So I think that's how we need to get these parameters here. And I'm guessing that's what's happening here too. And then it's expected to return that into this. And I think that's normal for CDECL, to pass these in the registers and then, or pass these on the stack and then return value in ST0. So I'm going to do that. That should actually be relatively easy, except I did do some stuff here with the XMM registers to load these before and do these checks against 0. Maybe I'll move them into these to make this easier. That'd be stupid though, wouldn't it? Because I could always do FLD0 and then compare it that way, which I think would be better. Yeah, I think that would be. Yeah, because if I remember remembering this correctly, we're comparing y first to 0, and then we can load x and do that. So I think what we want to do is we'll do an FLDZ to compare that. Although I remember this comparison stuff being a little nicer. I think we just do FLDZ, and then we'll load this from here, which will be FLD dword pointer x, and then we want to do the compare. And I always have to look this up because I always forget. I think we want f com I, and then we need to do I think though that this doesn't do sign compares in the same way, which is kind of annoying. You know what I'm actually going to do? I'm just going to be lazy here. And we're going to use SSE for these. And then what we can do is, do we even need an ESP here? We use it to load these, which I think we don't need to adjust here. So we'll do that, and then we don't need to push through this. And we can do a move APS into XMM1 dword PTR X, move APS XMM2, no, XMM0 is X, and XMM1 dword pointer Y. And then here, this was to get them out of XMM1, XMM0, but since they're already in those values, we can do this. Y and X here. So it's a bit shit doing it this way, but I can adjust this later anyway. Just trying to make this a little easier on myself. Again, we don't need these stack adjusts. Let's do ret undone. And like that. But this actually is line packed. These should be used, by the way. And these are going to be quad words. And again, we don't need these. And this will be y and x. I think that gives us what we need. A bit silly to mix and match these, but I think we're good here. Same results, which I would have expected. We can swap some stuff around here to make sure we're getting some actual values. Like 2 to the 3rd power should give us 8. And it doesn't. That should be 16. Right? No, that should be 8. I had that right the first time. That's a bit strange that didn't work, actually. Might be because we made this naked, actually. And if that's the case, I think I know how I want to fix that. But let's look in the debugger. Let's see what's going on here. See what code we got. And it ran the right one that time. That's good. And we're going to call main. Actually, we don't want the breakpoint here, do we? We want the breakpoint in here. I guess I was just worried that would move around, but it doesn't seem to move around much. No, breakpoint. Okay, good enough. Anyway, here, this is definitely passing that on the stack where ESP is. And if we look at the implementation for this, which I'll just step through this, because we're going to see we have XMM0 with this value in it, the input to that. And then it's gonna move it onto the stack. So what's about to happen here. And then we're gonna call this. Yeah, and so here you can see it does this with EBP plus 8. So I don't think the base pointer here is correct because we made this a naked function. This should actually be really easy to fix. As far as I know, this should be, we can just do it ourselves because this is gonna be the same everywhere, but it's gonna be push EBP, move EBP ESP, I think. And then here we do move ESP EBP, pop EBP, I think is what we do for this. And that should, if I remember this stuff enough, give us 8 here. And a crazy number for this POW, which might actually make sense. Let's test both of these with these values just to make sure they're the same for both of those things. And we get 8 in both. So that tells me, we can even do 3 here, and that should be 27, right? Yeah, that tells me that we're getting the arguments like we expect. And again, if we open that in the debugger just to double check, we should see what we want to see. Over all that stuff, cosine is still that polyfill. So yes, we're going to move APS to this, make some room on the stack, put that on the stack, and then do the call. And here we have push EBP and P here, like we expect, and then this should be loading those correctly. Do a couple of this stuff. It's actually calculating the POW here, fixing up the stack, and our ST0 should be our result. Where is that? X87. One of these. Probably that one. Yeah, ST0 here. And that's 27. And we're good. Okay. So that seems to be the issue. That even if we make this like a negative function, that we still need this stuff. Which is fine. So now if we copy and paste these back into WaveSabre, stuff should work. I mean, whether or not it actually does remains to be seen. But I'm guessing that's what the issue was. I really enjoy doing this stuff, by the way, you guys. Mucking around with this stuff. A lot of details, but it's really not that complicated. I also might not use SSE registers for these compares, but I just kind of like that. I remember the compares being a little less cumbersome with that, at least, but I'll have to probably look into both. But for now, we'll get it one step closer to where I want it to be at a time. Nice. This use is if I do Control Z after the paste, it'll undo the auto formatting. Oh, it actually did. Nice. I could have sworn it didn't last time I tried that, but happy to see that I was wrong. Anyway, this appears to work. I think I'm going to head out. And probably next time, depending on if I have time to work on this week or not, I'll be working on this next week. Anyway, thanks for hanging out, guys, and I'll see you next time.